Hey, good morning, everybody. My name's Edward Thomson, and today I want to talk about DevOps. Real quick introduction. I'm a program manager at Microsoft. I work on a product called Azure DevOps. The goal, of course, is to help you do DevOps better within your organization, to write code and get that code deployed quickly. I don't actually do that anymore. I don't write code anymore or deploy it because I am a program manager. Although once upon a time, I did actually write code. I did engineering both at Microsoft and at GitHub. So I do still remember a little bit about software development. So I hope you don't just have to take my word for it. I do actually, remember what it's like to actually write code. I'll give you more information about Azure DevOps as we go, but really I want to talk less about the product and more about the concept of DevOps, the idea, the philosophy of DevOps, and why it is so important. And to illustrate that, to illustrate why good software development and software delivery practices are so important, I'd like to tell you a little bit about a company called Knight Capital Group. If you already have heard of Knight Capital, this will be a good refresher, but if you haven't, this is quite a story. In 2012, Knight Capital Group was a high-frequency trading firm and a market maker in the US. They primarily traded in what are called dark pools. The idea of a dark pool is unlike where you and I go and trade commodities and buy stocks. A dark pool is where institutional traders go to do their trades. So it's not part of the New York Stock Exchange. It's just where two computers basically do their trading. Two high-frequency trading firms will actually just outside the purview of the New York Stock Exchange buy and sell commodities. And Knight was excellent at this. In 2012, they actually had a 17% market share of the New York Stock Exchange because they had the best engineers writing the best software. They had the best analysts building algorithms to buy and sell commodities. They had the best networks and the best networking team to support them. So they had the fastest connections into these private exchanges. And this was great. Everybody was happy except the New York Stock Exchange, because when you trade on these dark pools, the New York Stock Exchange doesn't get a cut. So the New York Stock Exchange decided to build their own dark pool, basically a private exchange just for high-frequency traders, algorithmic traders like Knight. And they were set to open on August 1, 2012, which was a Monday. So Knight got ready for the opening bell that Monday. They didn't change their algorithms. They didn't change their software itself, because those had been incredibly successful, right? They'd made millions of dollars, probably billions of dollars on these algorithms. What they did was they changed the protocols. So they ran wires that connected them to the new exchange that the New York Stock Exchange had set up. And they got their servers ready to speak that protocol. And over the weekend, they racked 8 servers ready to talk to the exchange. And they were really excited about the opening bell, 9:30 a.m. Monday morning. And when that opening bell struck, they immediately saw one thing very quickly. They were losing a ton of money. They didn't know why either. All they knew was that instead of taking their normal algorithmic positions, they were doing something very different. They were buying at the ask and selling at the bid. And I'm not a trader, so let me translate that for you. They were buying high and they were selling low. In other words, they were losing money on every trade they executed. They were losing about $175,000 every second. And they couldn't figure out why initially, but what they tracked down was that they'd done a bad deployment over the weekend. 7 of those 8 servers had gotten the latest version of the software that was ready to talk to the exchange. The last still thought it was in testing mode. So it wasn't executing real algorithmic trades, it was just making sure that it could talk to the test exchange. Except the test exchange wasn't the test exchange anymore, it was real life money being traded. Once they figured that out, they tried to update the deployment on the last server, but they got that wrong. Something went wrong in that deployment, and they started losing more money even faster. So they finally just went and pulled the literal plug out of the back of that machine to turn it off and stop all the trades on this network. And once they had done this, 45 minutes later, they started to unwind the positions that they'd gotten themselves into, right? Buying at just incredibly high prices. And once they finally did that, they realized that in those 45 minutes, they'd lost about $460 million and gone bankrupt. So, it is incredibly important in any industry that we have very reliable software development and software delivery practices. If you're offline, you're losing money. Your customers can't, book a hotel room, buy something on Amazon, whatever it is that your industry focuses on. It doesn't have to be finances. If you're offline, you're not making money. And so important fixes going out responsibly and quickly are critical. And that's where I think that DevOps comes in. Now, if you ask 10 different people what DevOps is, I suspect you'll get 20 different answers. A lot of people think it's about automation. A lot of people think it's about development teams and operation teams working together. And all of those things do make up a successful DevOps strategy. But at Microsoft, we have one single definition of DevOps. This comes from my buddy Donovan. If you've ever been interested in DevOps, Donovan Brown is the man that runs the DevOps show at Microsoft, and his definition is the one we use. DevOps is the union of people, process, and products to enable continuous delivery of value to your end users. And there's actually a lot going on in this sentence. But I think that the thing that's important here is that it isn't prescriptive. It isn't telling you that your dev team and your ops team needs to work together. This is really a goal. Our goal is to enable continuous delivery of value to your end users. It's not to ship software, at least not necessarily. That software has to actually have value when we ship it. And keeping our site online has value for the end user, so that's a goal as well. The other thing that I think is important is that it's the union of people, process, and products. In other words, despite the fact that I build a tool called Azure DevOps and want you to use a tool called Azure DevOps, that tool alone is not going to suddenly magically make you do DevOps. Instead, you need to invest in the people and the process. And I think that that's especially important. It really takes all the teams within your organization. It seems obvious that developers and ops make up DevOps, hence the name, but it also requires buy-in from the business. The business needs to understand how a DevOps philosophy will work in the organization and needs to enable that. And there's actually a lot of reason, a lot of rationale that a business team would want to do DevOps. I won't read you all this, but there's an organization called DORA. DORA stands for DevOps Research and Assessment. And DORA's goal is to do actual academic research on development teams and development processes and understand how high-performing, as they call them, teams succeed. And there is one particularly interesting statistic in here that I like, and that is that 70% of CIOs want to accelerate their business agility, that is, get software to market faster, get features to the customers faster. And they want to reduce IT costs. They want both of these two things, and they're willing to increase the business risk to get them. That's how badly they want them. And the interesting thing about DevOps is that it promises both increased business agility and reduced IT costs while reducing risk. So it's an incredible digital transformation that the business owners, I think, are easy to sell, easy to win over on. Fundamentally, you get faster time to market of your software, and you get increased revenue when you start adopting DevOps philosophies. This is something we've done throughout Microsoft, actually. We believe very much that getting our software into our end users' hands more quickly and more safely is very important to us. That's why you see things like the Insider Ring for Windows, the Fast Ring for Office, and our websites like Bing, like Azure DevOps, we can update incredibly quickly. Within Microsoft, we have tens of thousands of engineers using Azure DevOps on a day-to-day basis and deploying and building software in DevOps philosophies. Even in traditionally non-web-based or slow to update products, again, like Windows and Office. This is totally just a vanity metric, I admit, but we have about 82,000 deployments per day across all of Microsoft, whether that's a new version of Windows or new version of Office or an update to a website or a mobile app. And this took us a while, I'll admit. When I started at Microsoft, we didn't do DevOps. I'm not sure the word DevOps had been coined yet. What we did was the exact opposite of that. I started on what was then called Team Foundation Server, which is now the Azure DevOps team. And I started working on TFS in 2005, just before the release of Team Foundation Server 2005. And back then what happened was we would take the business owners, in other words, the vice president that ran this organization, and he would sit in a room with the program managers, and they would all figure out what we wanted to build over the next few years. And the program managers would plan it, then hand that plan over to the developers who would write a lot of code. And then the developers would hand that over to the testers who would find all the bugs in that code. And that process took years. So over the course of those years, we would eventually have a beta version of a product. We would hand it to you, our customers, and you would tell us what you didn't like about it. At which point we would say, sorry, it took 3 years to get here. We'll see what happens in the next release. And then the next release took 2 years. So we got better at this. We got better at planning. We got better at building software, and we got better at testing the software. And so we were really happy that the 3 years between TFS 2005 and 2008 became only 2 years between TFS 2008 and TFS 2010. But that's still not sufficient. So much changes in business in 2 years that when we start planning in 2008 what's going to be in the next product, the market looks very, very different in 2010. So we knew we still had a problem. And we started to try to understand how we could deliver this version, the next version, more quickly. And we didn't get there in 2012. That still took another 2 years. But we started to make progress on that between 2012 and 2013. That only took a year. Hey. The world still moves quickly in just 1 year. And if you look at this chart, you'd think that between 2013 and 2015, we totally forgot what we were doing. We lost the thought, and all of a sudden, we went from 1 year to 2 years again, which is technically true. But these version numbers are really decided by marketing. They don't mean much to me. When I look at the difference between TFS 2013 and 2015, what we started doing was what we called quarterly updates at the time. So every 3 months, we would give you a new version of Team Foundation Server. 2013.1, 2013.2, and this was a lot better. I mean, we went from 3 years between releases to 3 months. And so we were starting to really improve our agility and our processes to be able to get software out the door and in your hands more quickly. But what really changed this for us was moving from a box model where we write a bunch of code and hand it to you on a DVD or maybe a download, and you run it in your data center, to us actually running all of this code ourselves. So we started out with what we called TFS Online, which became Visual Studio Online, which has had a bunch of names throughout the course of its history, I regret. But it is now Azure DevOps. And with Azure DevOps, now we write the code and we do the operations of that. So you don't have to run anything in your data center. You just log in to a website that we operate and use it. Now, what we learned really, really quickly was that we didn't know anything about operations at the time. We had been used to writing a bunch of code, putting it in a box, and handing it to you, and you ran it in your data center, and we largely stayed hands-off. Once we had to operate it, now all of a sudden, we realized that we needed to be able to fix bugs in production immediately. Because if something's offline, we need to fix that as soon as possible. And now all of a sudden, we were starting to understand some of the operational challenges that you, our customers, have. And so what we actually ended up doing was taking all of this that we learned by building and operating a always-on, highly reliable website and putting it inside the box. So now, what we were building was basically a tool to help us and you build and maintain software. And so today, what was Team Foundation Server is now a number of small separate products within the Azure DevOps family. So we have Azure Boards that help you plan your release. We have Azure Repos, which help you write the code for your release. And we have Azure Pipelines that help you build that code and then deploy it, whether that's a server in your network on premises or a cloud provider like Azure or AWS. And despite the name Azure DevOps, and despite the fact that I would love it if you did deploy to Azure, we are actually very agnostic about the code that you're building, whether that's a mobile app or a desktop app or a web app, the architecture that you're using, whether it's Linux or Mac OS, Windows, or a phone, and where you're deploying it, whether that's to a cloud provider or on-prem. And our goal, by breaking what was, again, one big piece of software called Team Foundation Server up into multiple smaller pieces, is to allow you to take whatever you want out of that. If you are using GitHub for your version control, that's fine. If you don't need Azure Repos, that's fine. You're happy with GitHub, that we can still use Azure Pipelines to take your code out of GitHub, build it, and deploy it. If you're using Jira for planning, that's fine. You can integrate Jira with Azure Repos. And so for us, Azure DevOps has become the tool within Microsoft to enable DevOps practices throughout the entire company. So, again, for us, DevOps is the people, the process, and the products to enable continuous delivery of value. And so if we take a look more at the process, we can actually understand better what this means to us within Microsoft. So I think that any software project starts with the planning phase. Again, when I started at Microsoft, this was what we generally call a waterfall process, where we plan the next 3 years of work and then go do it, assuming that the competitive landscape won't change in those 3 years, assuming that we know what a customer wants and are willing to wager 3 years of our existence to get there, and assuming that we'll be successful at the end of it. None of those things are necessarily true. 3 years is a long time. And so one of the first things that we did at Microsoft was to move away from this waterfall planning model and move to an agile planning model. I think that agile methodologies are a prerequisite for a DevOps strategy. You can't be able to fix a bug in production in minutes if you're thinking about your software project on the scope of months or years. Obviously, you should have a high-level idea of where you want to be in a month or a year, but you shouldn't be actually planning work that's a year out, because that work will change. What we find is that with a traditional planning model, with a waterfall planning model, you lose value over time. You've got a really good idea of what is going to happen in your industry, in your company, in your product over the next few weeks. But as you go farther out, you start to lose a lot of value. You start to make more guesses and understand less what's actually happening in the company and in your industry. And so the real value is near-term planning. And you lose a lot in that far-term planning. So Agile encourages you to really not do it as much. Instead, what we want to do is do a little planning, write a little bit of code, and ship that code. Actually get a feature into production, into users' hands, and then start the planning cycle over again. So instead of a long-term planning process that has less value, if you look at that same duration of time in an Agile process, you actually get much more value out of it. And you get incremental software releases over time. So you can get feedback from your customers, and you can actually give them value. Because the point of writing software isn't really to write software, right? That just produces bugs. The point of writing software is to get that software into your users' hands and having them use it. That's why they pay us. Again, within the Azure DevOps landscape, if we break it down into multiple different products, the planning tool that we use is called Azure Boards. Azure Boards enables this Agile or Scrum type of planning. It allows us to break work down very simply. It supports a sprint-based workflow. So we can plan over the next 2, 3, 4 weeks what we're going to do. And we can actually track that as it's delivered throughout the sprint. So an idea starts on a backlog chart, on a Kanban board. It starts in the new column. We can visualize as a program manager, I know exactly what my team is working on. I know exactly what work is in progress, who's doing it. So I get insight into exactly who's doing what on a day-to-day basis. I know exactly what is being signed off on, what is going through test, and I have a high visibility into exactly what's going on in my software project. I think planning and tracking of work is absolutely critical, but from a developer's point of view, often we don't look at this big board. You know, I look at it from a project manager, from a product owner point of view, but as an engineer, I'm really less focused on who's doing what, except as it really impacts me. So as an engineer, my focus is really on the development portion of a DevOps process and the software development lifecycle. Within software development, there have been some really key changes that are adopted as a DevOps philosophy. I think the biggest one is pull requests. Pull requests, of course, allow for collaboration on code and code review to keep a high level of confidence. So it's very, very straightforward in a pull request to look at a couple lines of code and to make comments on them. When I started at Microsoft, when we did code reviews, I would actually sit down physically with a team member, and we would look at the code that I was changing or that he or she was changing and understand what was going on. Now, we've got websites like Azure repos, like GitHub, like really any code hosting repository allows you to do pull requests. And it allows you to visualize the code that's changing before it lands in master, and to be able to comment on it and have actual discussions, right? So this is a cute little comment, but there could be a thread here, understanding discussing the changes. I think most people are familiar with pull requests, so I won't belabor this too much. I think the other really fascinating thing to come out of a DevOps practice when it comes to development is getting rid of the traditional branching model. When I started at Microsoft, our branching model was complex, I think would be the most polite way I could possibly put it. The Team Foundation Server Team Foundation Server was actually called Visual Studio Team Foundation Server 2005. It may have even had a longer name than that. But the fact that we were called Visual Studio meant that we were actually in the same source code repository as Visual Studio, the IDE. Despite the fact that we shared exactly 0 lines of code with them, we were in the same repository. So that was the main branch. It had both Visual Studio and Team Foundation Server, which was weird. So we took a branch off of that. So we never actually collaborated with the VS team until it was actually time to ship and get our code into the main branch and into 2 separate boxes, but released at the same time. So we took a branch off of that. But by doing that, we did actually have to do some merges back and forth. Every once in a while, when we were getting ready to ship our code to them, we would do what we call a reverse integration, i.e. a merge from our branch into the main common branch. And they would do the same thing. And once that merge got done, we would merge back so that we had their latest code. And this happened over the course of several years a bunch of times. And it was terrible because merging a branch with the Visual Studio source code and a branch with the Team Foundation Server source code, even though they shared no lines of code, we had dependencies in common, like .NET and like different versions of Windows. And so whomever was doing this merge had to figure out all of these weird little dependency problems. We called it merge hell. But it was worse than that because our team also split up into feature branches. And so they would have individual branches for, say, the work item tracking functionality or the version control or builds. And they would have to do all these merges back and forth. And sometimes we would create more branches on top of that. We actually employed somebody whose job it was to do merges between branches. That's how bad this was. And it got worse because sometimes we would do a release and need to hotfix things and then create other branches. Fundamentally, what we found was that our branching model didn't make any sense from a logical standpoint, from a productivity standpoint. Our branching model only made sense in that we were branching to support the organization. It was kind of a variation on Conway's law, which suggests that we build inefficient communication systems within our organizations that mirror the org chart. In other words, we did the same thing with our version control setup. What I see, and what I would strongly encourage everybody to do, is to do nothing like what we used to do, and instead have a single master branch, trunk-based development. This is, I think, at the key of high-performing software development life cycles. You create a branch, you merge it. You don't let that branch hang out. You don't have long-running feature branches. You get your code into the master branch as quickly as possible. This is actually what the term continuous integration was coined to mean. If you have a feature branch, that's fine. If you don't want to show that feature to customers, that's fine. Use feature flags. Get that code into production so that you know how it responds in production. Because even if you're hiding the feature with feature flags, you may have changed some architectural subtlety, and you want fast validation. You want to understand that you've made a change that impacts production quickly. Because if that feature branch hangs out for a week or a month or 3 months, and you've made an architectural change, you may not get feedback on that until it finally gets merged. And if you've been working on that branch for 3 months, you may not know what actually the change was that you made. And so it's very easy to support a trunk-based development model with multiple people working in it because there are no long-running branches. That means there are no what we call big bang merges or merge hell. It's much, much easier to reason about. Microsoft has 2 different technologies for you as far as the version control aspect goes. First, we have Azure Repos. This is what we use internally within Microsoft. We make it available to you. This is what the Windows team uses. This is what the Azure DevOps team uses to do their development. We're moving the Office team onto this right now. A lot of teams within Microsoft were using version control systems that they built over the course of several years. And so moving them into Git has been a little challenging, but we're almost done with that. So Azure Repos supports both Git and a centralized version control system, supports pull requests, encourages trunk-based development, and is modeled as a version control system for your DevOps practices. We also happen to acquire this little company that you may have heard of called GitHub. And GitHub, we feel, is an excellent tool for open source development. This is where the open source community lives. And if you are doing open source, as we do within Microsoft, VS Code is hosted on GitHub. The .NET runtime itself is on GitHub. We think that this is an excellent place to do that. We also think that it's excellent if you want the open source model within your organization. We call that inner source around Microsoft. If you want to collaborate throughout your company, if you want to say open up all your repos so that everybody can see what each other is doing, potentially create pull requests from project to project, then GitHub is available as well. And all of the Azure DevOps tools are compatible with GitHub, and we're building richer and richer functionality between them. So Azure Boards now has really good integration with GitHub. We're improving that every day. Azure Pipelines, same. Once your code is written, though, it's not very valuable until it's actually in customers' hands. And the first step there is to take that code and build it and test it. In other words, to do the validation of that continuous integration. So you can have that trunk-based development model, and you can be merging code into master very, very quickly. But if it's not good code, then this is bad. I actually used to have a coworker who, not at Microsoft, let me just say. I have a coworker who would write a lot of code, check it in, get in his car, drive home. Sometimes you would do a get latest and that code wouldn't compile. Sometimes it wouldn't work, even if it did compile. And so the goal of software quality is around continuous integration builds. So once that code lands in master, we want to build it and we want to run our tests to make sure that the code is good. Even better if we can do that before it lands in master. So we can add a build step to our pull request process. And Azure Repos, GitHub, everybody can actually tie a build validation to a pull request so that you can't click merge on that pull request. The code can't go to master until a build runs and we validate that the code actually builds, the tests run, and we validate that the code is in fact good. This is what really allows us to have that productivity when it comes to our master branch, our trunk-based development, and getting code into master as quickly as possible. Again, what we used to do in the bad old days was write a lot of code. We would call ourselves code complete. Somewhere in the first 25, 30, 40% of the software development process. We thought we were done writing code at the beginning of the process because we had this test and stabilization step afterwards. So we'd write a lot of code, we'd hand it to the testers, and we'd say, we're done. The testers would say, this is garbage. They would look at it, find all the bugs that we didn't realize we had, and then we would have to go through this very long bug fixing process. And in a perfect world, we might have another shot at writing some more code, getting some more features in, if we could fix our bugs really quickly in the meantime. So our software quality, our bug count looked like this. We kind of knew we had some bugs, but we didn't think it was really very many because we're Microsoft. We're really good at writing software, right? Right, exactly. So what we discovered was that we had a lot of bugs. We could pay down that bug debt and then maybe take another whack at it. But fundamentally, we're carrying a lot of bugs around, as you laughed. I mean, we had a lot of bugs in the waterfall methodology. And so by breaking this down and planning on smaller sprints, by doing trunk-based development, what we see is we carry a lot fewer bugs around with us. On my team, we even have what we call a bug cap. And that's in order to make sure that we keep a finite number of bugs. So every engineer can carry the equivalent of 5 bugs. At that, if a team of, we're split up into about teams of 10. If a team hits 50 bugs, they have to stop working on features, go pay down the bug cap, go pay down technical debt, basically. I think a lot of teams have different ways to do that. Some have a 20% rule. 20% of your time is always working on fixing bugs. We actually have a cap. Whatever method you choose to enforce this, I strongly encourage you to work on that. The tool we use here is Azure Pipelines. This is what does our builds. So we have hosted in the cloud, we have Linux, we have Windows, of course, and we have macOS build agents that are ready to build, again, whatever tool with whatever technology it is that you want to actually build for your customers. Once you've got your code built, of course, we want to deploy it. And we think that continuous integration is important when it comes to your source code and your builds. Continuous deployment is key for DevOps. You want to be able to fix bugs as quickly as possible because, again, downtime means you are losing money. So the goal with our deployment is to automate as much as humanly possible. We don't want humans doing deployments. We want computers doing deployments that are running scripts. Because having this all predictable and repeatable means that when we have 8 servers that we need to update on a weekend before the market opens, we hit all 8 instead of only hitting 7. Or at least it gives us a much, much higher degree of confidence that we'll be able to do that. The other thing that we do, as far as a DevOps philosophy, is we do what's called progressive exposure or ringed deployments. In other words, we roll out changes incrementally. So you can do a canary deployment or a ringed deployment so that the first set of users sees your change. It's kind of like A/B testing, really. The first set of users sees your change. And if all of a sudden you start throwing a bunch of exceptions or people start complaining or there's massive amounts of downtime in that first ring, you stop. You go fix that. And the rest of your customers are blissfully unaware that there was a problem. But once everything does go well, you can roll out stage to stage, incrementally showing your customers that new functionality. This helps make sure that, that all of your customers don't experience a wide outage from a bit of bad source code. And we do this within Azure DevOps. Our internal users, me, the Windows team, they're the ones that get the buggy bits first. And they yell really loud. So make sure that your canary users, you have a way to understand when you do a bad deployment. Azure Pipelines doesn't just do builds, it also does the release step for us within Azure DevOps. Once your code is actually in production, though, you're not done. You still need to operate that. And so within DevOps, what really gives DevOps its name is that development and operations teams work together. We used to just write a bunch of code, put it in a box, and hand it to you to do the operations. There is no further from a dev and an ops perspective as 2 different companies and no feedback between them. So the goal within DevOps is to have a very tight feedback loop between the operations team and the developers. We actually do what we think of as running, as owning our code in production. So a developer writes code and then carries a pager. So we have a rotation within our development team that will actually get paged if their feature is down. So we have SREs, site reliability engineers, who do the initial first monitoring of functionality. So they'll triage issues, understand who needs to be paged, and then actually do that page to wake them up. So if you wrote a feature, you own it. There's no better way, we think, than to ensure quality than to wake somebody up at 2 a.m. when they check in buggy code. It will encourage you to write better code in the future. Finally, we talk about value. The goal of DevOps is to deliver value to our end users. We actually need to know if we're doing that. Right? We're not just writing code and throwing it on a website. We need to understand if the code that we're writing, the features that we're building, are meeting our customers' needs. So we need to understand from them if that's happening. Our definition of done is that we have the code live in production and collecting telemetry on its use. Is it slow? How fast does it take to close a pull request in Azure DevOps? Well, if we think that speed is value to our customers, and we do, then we need to have telemetry that tells us how long it takes. And so we need to be able to analyze that and understand if we're actually delivering software that is successful. So what we want is a feedback loop. We want to hypothesize that a feature is valuable. We want to go build that feature, and then we want to put it in production and get feedback from our users about whether it meets their needs or not. And that is that cycle within DevOps. So we can feed that learning, that understanding of production back into the planning process and refine improve our features and our functionality. So that is a very, very high-level overview of DevOps and the processes. I'm going to dig in this afternoon on Azure Pipelines if you want to better understand the build and the release aspects of the Azure DevOps product suite. But I hope that you will, if you're already doing DevOps, if you have a DevOps philosophy in your organization, I would challenge you that you're not done yet, that you can continue to refine that you can continue to improve your processes. So if you have any questions for me, I'll be around, and you can hit me up. I'm on Twitter. That's the best way to reach me. I'm Thomson. But I'll also be around for the rest of the day, so please feel free to ask me any questions. You can also shoot me an email. But that's all I got. So thank you so much for your time, and I hope that your DevOps practices improve.